Hey everyone, we're back for another video. This is 1-46 to 48 and I'm going to give you a hint for 49. 46 to 48, typically speaking, are probably the most confusing problems of the chapter, and they are always ones that students would ask me to do the first day of school once we got back from summer, because they wouldn't know how to do it during summer break. So you guys are lucky, because with the quarantine, I've learned how to make all these videos, and so I can do it for you now. All the other reasons that you're not lucky for the quarantine, well, here's a tiny good one. Okay, hopefully I make you laugh a little. 1-46, the planet Claire has pink air and some unusual inhabitants. Every citizen of planet Claire has either 1 or 5 pet rocks. You may assume there are equal number of 1 rock and 5 rock citizens, and the overall population of planet Claire is in the millions. A. Find the mean pet rock ownership of a citizen of planet Claire. Okay, so this is kind of like a weighted average, and it's going to look like basically a regular old average, but you have the mean, so half of the citizens have 5 pet rocks, and half of the citizens have 1 pet rock. It's kind of the same thing that you do when you're calculating a GPA. So, you know, you'd have 4 points for how many classes, plus 3 points for how many classes, and then divided by how many classes. Okay, this might look exactly like 5 plus 1 divided by 2, and that's because it is, which is 6 divided by 2, which is 3 rocks per citizen. Which makes sense, that if half of the population has 5 rocks and the other half of the population has 1 rock, that the average would be 3 rocks per citizen, even though there are no citizens with 3 rocks. Okay, find the population variance of pet rock ownership. Okay, so this is what we did in our last video. Luckily, there are only 2 values, so I'm going to take the mean, which is 3. I'm going to take 5 minus 3 squared and 1 minus 3 squared, so those are my 2 values, 5 and 1, minus the mean squared, so this is 2 squared, which is 4, 2 squared, which is 4. I'm going to add those together and get 8 divided by 2. I was going to do the answer there instead of the question. Divided by 2, because there were 2 values, the 5 and the 1, equals 4 rocks squared per citizen. So remember, we're working in variance, a little bit of a different units from standard deviation and the mean. Okay, let me just review this one more time. My 2 values I had were 5 rocks and 1 rock. I did 5 minus the mean squared, 1 minus the mean squared, took the sum and divided by how many values there were. There were 2 values, there were 5 and 1. Okay, number 47. I know it looks easy when I do it, but when you read this, it sounds so weird. NASA has sent a deep space probe to Claire to survey its citizens about pet rock ownership. Space travel is very expensive, and the probe only has the capacity to survey 2 citizens at random on the planet. There are 4 equally likely outcomes of pet rock ownership the NASA probe could find in its random survey of 2 citizens. List them. Okay, so NASA probe goes up. There's the possibility that it has a citizen with 1 rock and then another citizen with 1 rock. So this could be its sample. Or it might find a citizen with 1 rock and then a citizen with 5 rocks. Or it might find a citizen with 5 rocks and then a citizen with 1 rock. Or it might find a citizen with 5 rocks and another citizen with 5 rocks. So if it's going to send a probe and can only ask 2 citizens on the whole planet, these are all of the possibilities. Calculate a variance for each sample listed in part A. Okay, this can take us a minute. Okay, and what I want to do is keep these kind of separate here. Hopefully I gave myself enough room. Okay, so what is the mean between 1 and 1? One. Okay, now for the variance, I have two values, 1 and 1. I'm going to do the first one minus the mean squared, the second one minus the mean squared, add them, divide by how many values there were, and that's 0. Okay, why does that make sense? How spread out are these numbers? They're 0 spread out, because they're exactly the same number. Can you guys see another set of values of a sample that will also have a variance of 0? Yep, this one. And you don't even really have to calculate it. You just know the variance is going to be 0 because these numbers do not vary from each other. Okay, do you notice that these numbers and these numbers vary from each other the same amount? So whatever we get for this one, we will also be able to use for this one because they're the same distance apart from each other. Okay, so first I'm going to find the mean. 1 plus 5 over 2, which is 3. I think we did that up here. Okay. 1 minus 3 squared. And then 5 minus 3 squared equals 4. 4, 8, divided by 2 equals 4. And so we know this one will also be 4. Okay, does it make sense to you guys? I hope I can't ask you because you're not here. But making sure that the variance for this makes sense, that it's the same as the variance for that, because they vary the same amount. Okay, number 48. If NASA were able to send many of these probes, what would be the average value for the variance in pet rock ownership? Compare the population variance you found in part B of problem 46. Okay, so that's this, with the mean of the variances found in the samples. Okay, so what that means is find the average of these. Okay, and that's, I have a 0 and a 4 and a 4 and a 0. And I'm going to divide that by 4 because there were 4 values. So that's 8 over 4, which is 2 rocks squared per citizen. Okay, this did not equal this, so this is wrong. Nope. We need to get a calculation that equals this. So this is kind of what I was talking about in the end of the last video. It says for B, repeat your 4 variance calculations from part B of problem 47, this time dividing the sum of squared differences by n minus 1 or 1 instead of n or 2. The adjustment to the denominator makes each resulting value a sample variance. Okay, so this is kind of what I was getting at the end of the last video. There are 2 different types of variance and 2 different types of standard deviations. Okay, this we calculated was the sample variance, and the reason, the population variance, and the reason was because we divided by the number of values. Notice it did not get us the correct answer though. The answer was 4 for the population. We got 2, which is wrong. Okay, the reason is because we are working with samples. So when you are working with samples, you divide by n minus 1 instead of n. What that means is, since I have 2 numbers in my sample, I'm going to take this and divide by 2 minus 1 instead of divide by 2. And then you can see what happens. So I'm going to extend these lines down here so that you guys can see my work. Okay. So I am going to have the same numerator. It's just that I'm going to divide by 2 minus 1 instead of 2. So I'm looking at this part right here. And instead of number of values, I'm doing number of values minus 1. The reason I'm doing that is because I'm working with a sample, not the population. Okay, so that's 0 over 1, which is still 0. And this one over here is still going to be 0. Okay, now for these, we have 8 divided by 2 minus 1. So that would be 8 divided by 1, which is 8. And that will be the same for this one. Okay, so now what I'm going to do is repeat this calculation from A, and I'm going to show you that now I'm going to get the correct variance because I made that correction because I was working with a sample. So, mean of sample variances is 0 plus 8 plus 8 plus 0 over 4 values, which is 16 over 4, which is 4 rocks squared per citizen, which matches the correct population variance for rocks per citizen. So when you're working with a sample, which most of the time you will be working with a sample because you're not going to be able to get data on the entire population of Granny Smith apples or rhinoceros beetles or sleeping adorable golden retrievers next to my desk. You will probably only have a sample of those things. So most of the time you're going to end up using this minus 1 on the bottom. And I want to show you something for your calculator. Just one more time. Let's see if we can see it. The sample standard deviation is located here, S sub x, so that's where they have divided by n minus 1, and then the population standard deviation is here where they have divided by n. So it makes sense for S sub x to always be a little bit bigger because they have taken away one of the values that you divide by, so that means that you're dividing by less. Okay, now here's your hint for number 49. You still need to do number 49, but in the problem it says make a combination histogram and box plot starting at 70 with a bin width of 4. Okay, I have all of the trust, you guys can do that. Describe the center, shape, spread, and outliers. By the way, we call that SOX in stats. Use the mean and standard deviation if appropriate. Okay, so this is the part I wanted to give you the hint on. When is it appropriate to use the mean and standard deviation? If there is symmetry and no outliers. Use mean and standard deviation. if skew or outlier of any type, use median and IQR. This is your center, this is your spread in SOX. And then the shape and outliers, of course, we already learned how to determine if things are outliers. And the shape you'll have to see once you make the histogram. Okay, that's it. Thanks for listening. Hope you guys have a great day. I'll talk to you soon.